Okay, so please you can go ahead.
Oh, sorry. Okay. I hope my screen is visible now.
Yes, it is.
Okay. Good morning, everyone. My name is Kolawole, Oduremi. Today, we are diving into containerization with Docker. Docker is a technology that is fundamentally changing how we develop, ship, and run applications. To start with, let's compare containerization with traditional virtualization. In traditional virtualization, you typically work with virtual machines, VMs, as they say. Each VMs contains a full operating system and an application, also a hypervisor. This makes virtual machines quite heavy. They are in gigabytes. That is the size, and they are very slow to start. So containers, on the other hand, are much lightweight. They share the OS kernel, which means they don't need the full OS within their instance to operate. So container package the application and its dependency, ensuring the package the application and its dependency, ensuring that it can run reliably across any environment, which leads to them to several benefits. Container can start up quickly. They are small and they are very portable. You can easily move them from one different environment to the other, whether it's on your local machine, your testing environment, or a production server, or any remote server. So, what is Docker? Docker is the leading platform for containerization. It's the industry standard right now. Docker was introduced in 2013, and it quickly became popular due to its simplicity and efficiency. Docker consists of several key components, including Docker engine, Docker hub, and Docker compose. The Docker engine is the core component of Docker, which runs and manages containers. It provides the underlying infrastructure to create, deploy, and manage containers. In another we just say Docker engine is like the application you install on your infrastructure or your local system, while Docker hub is a cloud based repository. That is where many thousands of pre-built images, Docker images, are stored for a wide range of applications. You can go there and just pull them. Then we have a Docker Compose, which allows you to define and run multi-container Docker application, simplifying how the deployment and management is done. How does Docker works? Let's briefly discuss how Docker works. The core components here are Docker images and containers. Yes, Docker images and containers. Docker images are read-only templates that contain the application and its dependencies packaged together. I want you to think of them as a blueprint of your containers. Why Docker containers are instances of your Docker images that are running. These are lightweight and isolated from the host system. But they share, like I said before, they share the OS kernel. The Docker architecture consists of a client, the daemon, and registry. The client communicates with daemon, which manages Docker objects, and the registry, as we already know, is where Docker images are stored. They are the default registry. When you run a Docker container, the Docker client communicates with the daemon. Then the daemon pulls the image from registry. That is, if it's not locally on your system already, and then it creates and starts the container. So now let's talk about a few basic Docker commands. When you want to create and run containers, you use Docker run. You are not just going to use Docker run only. You are going to add other things. Like, for example, if we are going to run a sample hello world, just to check that everything runs well, you can use Docker run hello world. This is going to pull the hello world image from Docker hub, from the repository, and it's going to run the container on the infrastructure, be your local, your own system locally or a remote server. When you run this, Docker downloads the image, creates containers from it, and runs it. And it's going to output a simple message confirming that Docker is working correctly. So I want to show you how this works. A minute. I want to confirm if you can see my screen. Can you see my screen? Okay, thank you. So this is my, this is like a client now. It's my terminal. Yeah, it can be your CLI on your Windows system. So to practicalize what I just told you, you can run Docker run hello what. Now, you can see this is because I've already pulled this image before now, because I don't want to waste our time. Then we can put something that, this is just to show that Docker is running correctly on my system. For you to do this successfully, you have to install Docker engine on your system, which is the Docker application. I've already done that. Then to list containers that are running, or just containers that you have on your system, you can use Docker PS. Now this is because this is to show running containers for Docker PS. If you want to show other containers, you use Docker PS-A. So this is a list of containers I have on my system. They are not running. You can see it's showing that this is the one I just pulled 55 seconds ago. If you can see that. Then for us to stop or remove container, use Docker stops. But for us to start any of this running container, okay, we'll get there. But To remove, we use Docker rm. To stop, we use Docker stop. Then to also list Docker image, you can use Docker images, which we directly pull out the name, the image ID, and every other information is showing the size, whereby the other command shows the time, the status, and and all those information you can see there. You can see my screen, right? I'm trying to share something else. Now let's build and run our own Docker image, just to demonstrate what we have been talking about. We are going to create a simple Node.js web application and package it into a Docker container, allowing us to run and deploy it consistently across different environments. Now we are going to use a Docker file. This is a screenshot of a sample Docker file that we are going to use. If you look at it very well, it's showing from Node. Docker file is just a text file that defines our Docker image. It shows node from node 20 working directory, my app, copy, then run npm install, expose it, then the command. So let's explain what this means. A Docker file is a text file that contains instruction for building a Docker image. The from instruction specifies the base image to use for the build. This is the starting point for the image. As you can see, it's where the whole thing started from. Then there is working directory, which shows where we are working from. We are going to see that when I show you my terminal. Then there is copy and run. The copy instruction copies files or directory from the host environment into the container file system. The run instruction executes a command and commits the result as a new layer in the image. While the cmd, which is like command, the instruction set the default command to be executed when the container starts. Now, if you can see my screen, you see a screenshot of what I've been talking about. You see the Docker desktop, which is the Docker engine, which is going to run. We are going to use to demonstrate this. So let me show you. Can you see my screen? Hello, are you with me?
Yeah, we can see your screen.
Yeah, this is Docker. This is Docker engine that I've been talking about. If you can see some containers that have already pulled. You see the hello word that we pulled recently. You see it right there, showing 5 minutes ago. These are other that I've already pulled. So I'm going to show you. Let me show you my terminal now. Okay, this is I pulled. This is my Docker file. Like this is my working directory now, my app. If you can see it, inside this directory, I have Docker file, app.js, node modules, and every other thing you can see right there. The Docker file is just this. Yeah, just what what was displayed in the screenshot. You can see out how it works. I already have the Docker container. Copy. Yeah, which is my web app. So to start this, I'm just going to use the command docker start, then the container ID. To check whether it is running, you use docker ps, and you see that the status is showing that it's up and running just 6 seconds ago. Now, if you go to your Docker container, Docker engine, you are going to see there it will show that it's running. If you look at the Docker file, you notice expose 3000, which is telling the engine to expose port 3000 on the network. So if we go to our local host and we check through local host port 3000, this application will be right there running. I'm going to show you that. Okay, you can see my web app is running on port 3000. If you click on this, it's going to show the app. Let me show you what the app. Can you see this? It's running on port 3000. Can you see it? Are you with me? Can you see it? Hello?
Yeah, we can see it. We can see it.
Yeah, we can.
All right. Thank you. So I'll be able to. I'm trying to share the main slide. So that's just a basic demonstration of how to deploy a simple Docker image. Then what are the use cases of containerization? We have microservices architecture. You can use that to containerize individual microservices, which allows for easier scaling, deployment, and isolation of application components. It is also used in continuous integration and deployment. You can also use it in cloud and serverless platforms, developer environment, machine learning and data science, and you can also use it for Internet of Things. So what is the future of containerization? These are just predicted future of containerization. It is assumed that containerization will be a widespread adoption of serverless containerization for event-driven application. That will be around 2025. Integration of container orchestration with machine learning for predictive scaling and source optimization. in another 3 years' time. And in 2030, it is predicted for advancement in container security with hardware-based isolation and real-time threat detection. In 2032, it is predicted for emergence of self-healing and auto-updating container environment for improved reliability. Then in 2035, it is predicted for convergence of containerization and cloud-native technologies for seamless multi-cloud deployments. To wrap up, we have talked about Docker's role in modern infrastructure, and then we have also seen basic Docker commands. So are we open floor for question and answer? Then after that, I have some questions to ask you, just to be sure that we are following. Does anybody have a question? Okay, in the absence of none, if you are following me, please can somebody say something to the mic? I can't, it seems I'm the only one here. Hello?
Yeah.
Okay. Okay, my own questions now. The first question, why should you use Docker instead of traditional virtual machines? The options: A, Docker containers are more lightweight with and lower resource usage. B, Docker requires more hardware resources than traditional virtual machines. C, Docker containers run multiple operating systems, just like VMs. D, Docker is slower, but offers better isolation compared to VMs. Who can help us with that? Anybody?
Okay, I'll go with option A.
Mr. Samuel, thank you. That's correct. The second question, what is the advantage of using a Docker file to build an image? Option A, a Docker file automates the image creation process, ensuring consistency. A Docker file is not necessary and can be ignored. C,
I'll go for A.
You go for A. Okay, that's correct. Somebody has a question. Can one use Docker without installing it in your local machine? Is there a way for that? Unless you have it, if your infrastructure is a remote server, but wherever you want to run Docker must be installed on it. It's as simple as that. If where you want to use it is your local system, then it has to be installed on it. The only way you don't need to install is if you are remotely accessing an infrastructure, then that infrastructure must have a Docker installed on it. So thank you, everyone. We have come to the end. Thank you. Victoria, are you
All right.
here?
Thank you so much, Paula. Thank you for the wonderful presentation. We do appreciate. Okay, then